This evening on the bench, I've got a little portable VHF airband radio from the circus, mid-80s, I suppose, to the early 90s. These were quite a popular little radio for sort of a semi-serious sort of airband listener. They weren't synthesized; they were a analog VCO type tuning system on them. They were also used for a lot of the parachutists used to use them. They used to have one of these in your on your parachute, and if you were being trained, you would tune into one of the sort of like the tower frequency of the airfield you were using, and the instructor would communicate until you went to open your parachute and obviously follow instructions and things like that. Now this model is the R-537s. There are various models. This is one of the slightly higher range ones with 2 crystal options, so you've got an option for selecting different crystals. Now I'd like to mention that I bought this on eBay and it was listed as collection only, and I was watching it for a couple of weeks and I was thinking, I can't drive to get it. They don't often come up that often, so I thought, well, I'll take a chance and ask the seller if he'd be kind enough to send it to me. And I said I'm a YouTube channel. I'd like to restore it and sort of, it'd be interesting. And I think he was a bit worried he'd been maybe scammed at some point, and he wasn't happy about sending it out, which I can understand. That's fine. Anyway, I didn't hear anything for a couple of days, and then he contacted me and said, yes, I will send it out to you, no problem at all. So he very kindly sent this radio out to me, and it arrived this afternoon, and going to have a look at it this evening to see what it's like. Now, I do know from the photographs he sent me, and he's very honest, he said that it had some pretty bad dents in it. No one really knows why, he said, and it does look like something's been dropped on it, basically. But these things are pretty tough, and he said it still works. So this is pretty going to be more of a sort of like a restoration of the cabinet, and try and get the dents out and make it look as nice as I can without respraying it and things like that. So let's, without further ado, let's get it out of its box. Here we go. And this is it. So it comes with a little leather case, or leatherette case. It's not real leather, so that's nice. It's a nice option. Here's the radio itself, and you've probably seen these before. They were, if you're into sort of amateur radio or any sort of communications radios, you've probably seen these before. Now you can see the dent in it. It's got quite a big crease across the. There you go. Catch it in the light. You see it's got quite a big dent on that side. There's a smaller dents on the other side, but they're not so bad. And this is the top. Here we got our squelch control here. We've got volume here. This is our adjustment for our frequency as a VCO, or VFO should I say, and your fix option is for the crystals. Now I'm not sure, I think you can select 2 different crystals. Oh, there we go, yeah, A and B are the crystals. So the first thing to do is I'm going to just take the covers off it, see if we can straighten out some of these dings, and then what we'll do, if I can get that cabinet look reasonable, then we'll put it back together. We'll have a listen and see what it sounds. I just want to make sure also that nothing's interfering with any of the electronics inside. I'm pretty sure it's not, but let's get these sort of dents knocked out of here a bit, and then see how we go from there. Well, isn't that lovely made? That's the inside of it. That's with the rear cover off and the front cover's off. I just got to unsolder the speaker so we can get to it and straighten it out. You can see it's there's obviously the battery compartment. There's the section there for the crystals. This is obviously all the local oscillator section. You've got very few adjustments actually inside. Looks like we've got a couple of IF transformers down the bottom here, an op amplifier here, a little JRC operational amplifier. Really nicely made out, and you can see how robust it is, and you see that it's obviously can survive quite a heavy impact. Let's turn it over so you can see the other side, and that's the other side of it. There's your tuning wheel there, and a ceramic couple of bodge capacitors on the back, probably just to trim something up, or just maybe decoupling, something like that. Nicely made, and absolutely suffered no damage at all. So basically we need to now just try and see if we can straighten out these cases. So what I'm going to do is unsolder that speaker, which is here. Just to show you there's only a little tiny speaker in here, but it's a 4 ohm speaker, 0.2 watt. No, it's not, it's an 8 ohm speaker with 0.2 watt. We'll get this, try and get the back, we'll start the back panel and see if we can get these sort of subtle dents out. It's difficult to see in the right light. There you go, you see there's 2 dents there. try and get those out, and then we'll move on to the speaker side. So let's start with this one. Okay, every workshop should have a hammer, and this is my rawhide hammer that I use for knocking dents out of things, and hopefully this will be sufficient to knock this one out. So the plan is to just basically turn this cabinet over, and then we'll try and knock these dents out. So I'm using the base of the bench, which is clean, to try and use this as like a mandrel to press this out. So you can just see the divot here. There's a high pot here. I'm just going to give it a whack. Still just about make the divot out, but it's better than it was. It's much better. You can see that it's very faint now. And you can go too far, because obviously this has got a bit of a give in it, so you don't want to go too far. Just going to try it a bit more. Yeah, it's pretty good. And just work around it. Let's more or less knock that out, that one. So let's try this one in the corner here. Now this one might be a bit trickier. You can see actually the bend in the case there. So let's try and knock that one out. It's better. Still a few. You're never going to get it perfect, but I certainly want to get it as best I can. Just go around, just. That's pretty good actually. That's actually better than the first one. So just going to go around again on the other one. Just go around in a woodpecker it flat. That's pretty good. I hardly see a dent in that now. That one's actually come out better, I think, than the other one. It's very hard to see if I've actually gone too far. You can actually go back again. Just get it in the light. Just give it a. If you think you've gone too far, just tap it back gently. It seems to me that you probably won't see with the camera, but there's a high spot here and a lower spot there. So let's just try it on the edge of the hammer. Oh, that's better. Yeah, that's knocked it out better. So I'm pretty pleased with that. That's a pretty flat case now. So that's that rear cover done. Let's get the other cover disconnected from the speaker. We'll have a go at that as well. Okay, this is the front cover. I've taken the cover off where the crystals go. The speaker's still in situ. I don't want to remove the speaker unless I have to, but I'll have a go first to try and get this horrible dent out here, this horrible crease here. So we'll try that first. I'm not sure if I'm going to actually be able to do it without the speaker in place. I think that speaker's going to have to come out. So let's try and get the speaker out, and then we'll clear this area and I can work on it properly. Okay, and the speaker lifted out very easy. That's not a problem at all. So just remove that. That's good. And we're going to remove this speaker cloth, for want of a better word. Maybe we might not need to actually. Might use that as a cushion. Alright, so let's try and get this dent out here. I can sort of see the crease along here. So similar thing, make sure your bench is clear. Just go around. That's pretty good, isn't it? I mean, I still see a slight mark, but it's more or less impossible to. Yeah, I mean, you've got a couple of scratch marks here, but there's a little bit more maybe. It's pretty good, isn't it? Pretty pleased with that. We might be able to do something with that as well. If I can find some matching paint to fill in those scratches. Just a few more. Yeah, that's pretty good. Just showing the different light. It's much better, isn't it? Is that better? Tell me if it's better. Okay, so let's get the speaker reconnected and we'll try it. Okay, clearly got some signs of life because we've got audio. So what we'll do is we'll just chuck in a couple of frequencies into the signal generator. So we're tuned to 126 on the dial at the moment. I think we can bring you down and zoom in a bit so you can see it a bit easier. We'll just check to see if our scale accuracy. These are usually pretty accurate. These on these radios. So let's type in. Might excuse my arm. Carrier frequency 126 megahertz. RF level minus 20 dB. And let's look at tune around so we can hear. And let's modulate with it. So we need AM modulation with about 25%. And I suppose we could connect an aerial up to the signal generator would be useful. I'm not going to get anything otherwise. So let's connect with an aerial. Have a tune. There it is. Okay, so scale calibration is a little bit off, but that's not a problem. We could probably adjust that up if we can work out where our local oscillator is. So the radio is clearly working. Let's try a higher. Let's try 118. Yeah, slightly off as well, but clearly working fine. And it might actually come in when I've got the metal cover on the back. It might be a capacitive thing. Once I've got the back of the radio on, it might bring the tuning in slightly because the tuning capacitor is right against the wall. Let's just see if it does. It doesn't seem to make any difference, but okay, so we've got a very slight misalignment there, but the radio is working, which is excellent. So let's put the back cover on and try and see if we can get this alignment any better. Right, we're tuned in exactly to 118 megahertz on the dial, and it looks like this is the local oscillator coil. Obviously, just a fixed coil, not like a normal sort of screw inductor. This is a lot of the way they used to do it. So I'm going to just try and. Okay, so we can alter the frequency. So you hear that. Let's put the squelch on. Ready? Okay, so what we're going to do is just adjust this very slightly to try and bring this into line. So I'm going to let's just trim. Okay, I made it worse, so I've got to close this up a bit. A little bit closer. I'm going to use a pair of pliers just to pull it together. So I'm going to turn the radio off. Actually, shorting this out shouldn't actually cause any problem because it's a basic short anyway. But just close this up very slightly. And you see our dial now is pretty good on 118. Okay, so let's try it at the higher end. Now we've got a trimming capacitor for that. Bear in mind I'm doing this blind because I haven't got the manual, so this should be 135 megs. 135 meg. Pretty good. A little bit out. We should be able to trim that in with the trimming capacitor. Let's try it at 130 meg. Spot on, that's good. So we've got a very, very slight alignment error, but not really that worried about it. The rest of the thing with like the IF is probably not necessary to align it, but I will just check it, and then what we'll do is we'll pop it back together, give it a bit of a clean up on the top panel, just to make it look a bit nicer, glue the speaker back in, and we'll give it a try. Okay, just before I put it back together, just interesting enough to just check in and see what maker capacitors it used. I thought they might be Rubicons or something, but they're Shoei. Now, I've come across Shoei capacitors before. I'm intrigued by this because Shoei is a manufacturer of crash helmet. If you're a motorcyclist, which I know some of you are, you'd know the name Shoei, and I'm wondering if they're the same capacitors. But radio seems to be working fine. I'm not going to bother changing capacitors just because I'm suspicious of them. This set is unlikely to have dried up capacitors anyway because it doesn't run warm. It's sort of like a pocket radio, and these capacitors will probably last the lifetime of the radio, to be honest with you. So it's all back together, and it's in nice condition. So let's get the covers back on it and have a proper listen and check the scale calibration. Okay, I found this label on the bottom of the radio underneath the battery compartment that actually says all the information about the manufacturer, the model number, serial number, and things like that, sort of frequency range. I thought it might be interesting to show you. So basically, I've got the cabinet straightened out. Let me just zoom out a bit. Now, the reason why it was dented so easy was this is a very thin aluminium, and this case here was slightly bent. This is the cover that goes over the crystals. and I managed to bend it straight, but it is so soft. So, you know, if you put this in your back pocket and sat down on a hard bench, you just bend it all up. So they are fragile. They're obviously made of aluminium and that's why I didn't interfere with the tuning capacitor when I stuck the back on of the radio. It didn't make any difference. There's no iron in the metal. It's like aluminium, and therefore it didn't detune the set. But it's certainly working okay. So I'm just going to. I can't. There's nothing flying at the moment. Obviously, we're still in lockdown. There's no sort of air traffic about at all, really, at Gatwick. I mean, there's a few odd planes going in and out. But I'll just do a couple of spikes on plots on the signal generator, and we'll see if they're roughly in line on the tuning dial. So let's do that next. Okay, all we can do really is check the final alignment just to see if it's roughly in where it should be. So let's tune to, let's go to 118 megahertz, close I can see on the dial. Switch the generator back on and type in 118 megahertz. And there's some modulation on it. Just tune, just so we get it. No modulation. No. Oh, come on, 25. Okay, there's that 25. We're slightly off. Slightly off with the cover on it. It has actually pulled it back slightly. Okay, so let's try it at 124. Not far out, but it's very slightly out, but it's probably perfectly okay. 136 meg. That's pretty good. So it's very slightly out at 118. Let's just set it again between the two pimples. Yeah, very slightly off on the low frequency. It's about 117.8, something like that, but it's not that critical. It's only a ballpark figure thing. It's not like a digital readout or anything. So set seems to work really well. No problem with sensitivity as far as I can tell. I don't know what the specs are for sensitivity, but it's a nice little radio. Managed to knock out most of the dents without any problem. So it's sort of like it looks in pretty nice condition now, as you can see. There's the back panel there. I can see a few, I don't know if you'll be able to see them, but there's very, very mild dent there. But because it's aluminium, it's very difficult to get the rest of them out. It's perfectly acceptable. It's far, far better than it was before. So that's it, really. That's the Signal R-537s. Thanks for watching, and more to come.